Okay, so we're back now with part 3 of lesson 8.1. So now we want to talk about vector addition. So first, got to state this, just ignore this line, that's not supposed to be there. All right, so we have two lines. We have vector v and we have vector w, and they both come from the origin, and their endpoints are listed. So vector v is at -2, 5, and vector w is at 7, 1. And so the question is, how do you think you would calculate v plus w using the graph or using the coordinates? So there's a couple things that we can do to figure this out, and it all works together. One way, and this is kind of neat, is we can put the tail of vector v on the tip of w, okay? And we just simply call this tip to tail, all right? It's a very handy method. So essentially, we're taking this and shifting it over so that it's still going at, the same rate and direction that it would be. So you'll notice that, so if this is where the tip is, so this line goes over 2 and goes up 5. So I would want to go over 2 and then up 5. 1, 2, 3, 4, 5. And I believe that lines up, yep, because it's at 6. So I could do that. And now I can draw a line here. This line would represent the vector that we would get if we added vector v to vector w. So this is a really easy graphical pictorial way to do this. It's very visual. But now we want to say, well, like, how could we do this in an actual addition method? And so the way we can do that is we can simply take the coordinates, the x coordinates of both, and add them together, and the y coordinates of both, and add them together. So essentially what that looks like is we would have -2 plus 7, and then we would have 5 plus 1. Okay? And what that is going to do for us is it's going to give us the new coordinate of, let's see, -2 plus 7, that's going to be 5. 5 plus 1 is going to be 6. So what does this mean? Well, this shows us the end point of this because we know it's coming from the origin. Let's see. Does it go out 5? Yep. Does it go up 6? You bet. So it's just kind of a nice pictorial way of showing how that connects together. How do you think you would calculate w plus v? So this first one was v plus w, right? Because we took the v's first and then added them to the w's. So how would you calculate w plus v? Well, very, very simple. We would just reverse that process. We would take the w's first. So my w here is 7. And then I'm going to add it to -2. And then for my other one, I'm going to take 1. I'm going to add it to 5. And you'll notice that when I do this, in this case, I still get the same answer. I still get that same one. So you can see that addition is going to work both ways. It's kind of like if I add 3 to 5, I get 8, or if I add 5 to 3, I still get 8. So I'm still going to end up in the same area. So the question here is addition commutative? Absolutely, yes, 100%. All right, so now let's look at subtraction. So again, we've got our same vectors, and again, we can just ignore these vectors down here. They don't mean much of anything. All right, and we have our vectors here. We've got vector v again, vector w. How can we subtract them? So starting out, if we had negative 2, 5, 7, 1, negative v would go in opposite direction. Okay, so think of it this way. V is going this way. If we had a negative v, it'd be going in the absolute opposite direction from this one. And the same with w. So that means w would technically be going this way. V would be going this way. And we can see, where we would get that new line. Another way that we can do this through calculating is that if we have, for example, a minus b would be the same as a plus negative b, right? Those are basically saying the same things. A minus b is the same thing as a plus negative b. So if we want, we can use that to actually do some of our calculations. So, and then it says, what is negative v? It's the same thing as this. Now it wants us to calculate. I'm sorry, hold on, I'm in the wrong place. All right, there we go. So what is negative v? Let's get back to them. It's the same magnitude, but different direction. Okay, we've got a different direction. And so now, if we were to look at this, we know, for example, if we had v plus negative v, well, those points would be 0, 0, right? Now, let's actually do a calculation, okay? Let's take, w minus v or w plus negative v. It's the same thing. And we're going to use our points. So we're starting with w. So we've got 7. And what are we doing? We are subtracting negative 2. So we're subtracting negative 2, which is basically the same thing as adding 2. Okay? And then for the other one, we're taking 1, and we are subtracting 5. And so then what do we get for a point? We're going to get 9, negative 4. And so on this, we would go all the way out to 9, and we would go down to negative 4. And that would technically be our new vector. Okay, that's our new line through the process of subtracting these two vectors. Notice it's now going in the opposite direction of any of these vectors. Okay,